comet-sized object is called 3I Atlas, and during observation, scientists have been seeing it change color and even grow a cometary tail. Their findings have led to some belief that this object may actually be made by another life form.
Something just changed. For as long as we have looked to the stars, we've had a script for how comets are supposed to behave. They're ancient, dirty snowballs on long journeys through space. As they get close to a star, they warm up and they release gas and dust. It creates a magnificent tail that always points away from the heat. That's the script. But what if a visitor showed up that refused to follow those rules? What if it challenged the very models we use to understand them? In the quiet of July 2025, that is exactly what happened. This is 3I Atlas, an interstellar traveler that isn't just a puzzle for astronomers, it's forcing them to question our fundamental understanding of what a comet can be. As it tumbles through our solar system, it's exhibiting a string of behaviors so bizarre, so unexpected, that some of the world's most respected scientists are now openly asking if we're looking at a natural object at all. In this video, we're going to break down 9 startling anomalies of 3I Atlas that have the scientific community scrambling for answers. We'll explore the observations that seem to be rewriting the textbooks on comets and delve into the thrilling and maybe even unsettling possibility that we've been visited by something far more complex than just a rock from another star. Our story starts on July 1st, 2025. In the mountains of Chile, a robotic telescope, part of the ATLAS survey, which stands for Asteroid Terrestrial Impact Last Alert System, flagged a faint, fast-moving object. At first, just another blip in a vast field of cosmic data. But as observatories around the world, from Hubble to the James Webb Space Telescope, turned their attention to it and started crunching the numbers, a startling picture began to form. The object was on a hyperbolic trajectory. That's an astronomical game-changer. It means the object is moving so fast that our sun's gravity can't capture it. It isn't from here. It was a visitor, a traveler from the immense darkness between the stars. The object was officially named 3I Atlas. The 3I tells us it's only the third confirmed interstellar object we've ever detected. It follows the bizarre cigar-shaped Oumuamua from 2017 and the much more conventional comet 2I Borisov from 2019. Oumuamua was strange. It didn't have a visible cometary tail, but it accelerated as if something was pushing it, which sparked some wild speculation. 2I Borisov, on the other hand, was comforting. It looked and behaved just like the comets from our own solar system. It suggested that maybe, just maybe, comets were similar everywhere. 3I Atlas would shatter that comfort. Follow-up observations quickly confirmed the object was active with a fuzzy coma of gas and dust. But as the world's most powerful telescopes tracked its journey, they revealed that 3I Atlas was following a script all its own. Each new piece of data just made the mystery deeper. Scientists were about to see a series of events that would challenge everything they thought they knew. As 3I Atlas moves through our solar system, it's not breaking the fundamental laws of physics, but it is presenting a cascade of anomalies, 9 great questions that are forcing astronomers to search for new explanations. Here's where it gets strange. Anomaly number 1, the unconventional jet system. In recent months, high-resolution images have revealed a complex structure of at least 7 distinct jets of gas and dust erupting from the comet. This by itself isn't unheard of, but the orientation of these jets is baffling. Some point away from the sun, as expected, but others appear to be pointing towards the sun. This feature, an anti-tail, isn't just an optical illusion caused by our viewing angle. It appears to be an actual jet of material shooting in the wrong direction, a behavior that directly challenges our models of cometary activity. Anomaly number 2, the unexplained acceleration. Maybe the most significant puzzle is the comet's motion. NASA's Jet Propulsion Laboratory has confirmed that 3I Atlas is showing non-gravitational acceleration. Something other than the gravity of the sun and planets is giving it a push. For comets, that's normal. The outgassing of gas and dust acts like a rocket engine. But the case of 3I Atlas is different. The acceleration is significant, but observers have struggled to see a cometary tail massive enough to explain such a powerful push. This was the exact same mystery that plagued Oumuamua. Is the outgassing just composed of materials we can't easily see, or is the push coming from something else entirely? Anomaly number 3. The composition doesn't add up. The composition analysis shows something that doesn't match any comet we've ever studied. Data from the James Webb Space Telescope shows that carbon dioxide dominates the emissions at a ratio 7.6 times more abundant than water. Comets are supposed to be dirty snowballs, mostly water ice. This one barely qualifies. But wait, there's more that doesn't add up. Spectroscopic data from the Very Large Telescope detected atomic nickel in the coma. While nickel itself is not unheard of, some early analyses noted a curious imbalance in the nickel-to-iron ratio, which some reports claimed was more in line with industrial alloys than natural cosmic dust. While this might be explained by complex chemistry at large distances from the sun, it's another data point that doesn't quite fit the standard model.
Anomaly number 5, the statistical improbability. An object of this size, potentially up to 5.6 kilometers in diameter, arriving on an interstellar path is a statistical rarity. Our models of how planetary systems form and eject objects suggest that smaller bodies should be far more common. Finding a visitor as large as 3I Atlas as only our third confirmed interstellar object is statistically unlikely. If its size is confirmed to be on the larger end of estimates, its very existence challenges our understanding of planetary formation. Anomaly number 6. Extreme activity with bizarre stability. The comet is undeniably active. This level of outgassing should be chaotic, causing the comet's rotation and trajectory to become erratic. Yet, 3I Atlas remains remarkably stable on its path. Its trajectory shows that smooth non-gravitational acceleration, but it isn't wobbling or deflecting wildly. How can an object be so active yet maintain such a controlled path? The natural explanation is that the object is extraordinarily massive, so much so that even this violent activity barely affects its momentum, reinforcing the questions about its large size.
Anomaly number 7. The light that shouldn't be. When astronomers studied the light reflecting off 3I/Atlas using a technique called polarimetry, they found another anomaly. Data from the Very Large Telescope revealed light scattering properties that were described as unprecedented among comets. The measurements showed an extremely deep and narrow negative polarization, a signature that sets it apart from both solar system comets and our previous interstellar visitor, 2I/Borisov. This implies the very stuff 3I/Atlas is made of could be fundamentally different. Anomaly number 8. The galactic forge. Where did this strange composition come from? Some researchers have run computer simulations, and what they found rewrites our understanding of interstellar objects. Galactic cosmic rays, particles accelerated by ancient supernovae, may have bombarded this comet for billions of years. These high-energy particles could have penetrated its surface, breaking apart molecules like carbon monoxide and reforming them into the carbon dioxide that now dominates its emissions. It's a cosmic forge running for eons that may have created a 15 to 20 meter thick crust of irradiated organic-rich material, unlike anything we've seen up close. Anomaly number 9. The impossible orbit. Finally, there's the trajectory itself. 3I/Atlas is moving in a retrograde orbit, opposite to the planets, but its path is tilted only about 5 degrees relative to the ecliptic plane, the flat disk in which all our planets orbit. The statistical likelihood of a random interstellar object arriving on such a precise, yet backward path is estimated to be incredibly low. It's like threading a needle from across the stadium. It's so unlikely, it makes you stop and wonder if it was truly a random shot. This cascade of anomalies has, maybe inevitably, sparked one of the most profound debates in modern astronomy. On one side, the overwhelming consensus is that 3I/8 is a natural, though highly unusual comet. Proponents argue we have a tiny statistical sample of only 3 interstellar objects. We simply don't know what normal is. This comet may have formed in a completely different type of star system, giving it a chemical composition we're not used to. In this view, 3I/8 isn't breaking the laws of physics, it's exposing the gaps in our own knowledge. It is a natural wonder that will force us to rewrite the textbooks. On the other side is a far more provocative hypothesis, championed most notably by Harvard astrophysicist Avi Loeb. He argues that when faced with so many anomalies, we must at least consider the possibility that 3I/8 is not natural. He has cautiously proposed it could be a piece of extraterrestrial technology. In this speculative framework, the anomalies are reinterpreted. The complex jets could be thrusters. The non-gravitational acceleration without a massive visible tail could be the signature of an engine. The extreme polarization and strange chemistry could be signs of artificial materials. Loeb and others are careful to frame this as a testable hypothesis, not a conclusion. They argue that the lack of a massive, obvious cometary tail, a feature some observers have noted, is particularly compelling. If an object accelerates without showing the expected plume of gas and dust, the technological hypothesis, however unlikely, becomes harder to simply dismiss. NASA and the mainstream astronomical community have firmly stated that the data is consistent with a natural, though strange, interstellar comet. As 3I/8 continues its journey, passing Jupiter's orbit in 2026, it leaves behind a wake of deep and unsettling questions. We are left with a cosmic riddle. Is this a once-in-a-generation natural phenomenon, a messenger from a distant star system so different from our own it expands our definition of what a comet can be? Is it a ghost from an ancient solar system, possibly older than our own, made of materials we've never seen before? Or is it something more? Is it the definitive evidence that we are not alone in the universe? For now, all we can do is watch and wonder. The world's observatories will keep tracking this object, searching for the final clues to unlock its identity. Whatever the answer is, 3I/8 has already shown us that the universe is far stranger and more mysterious than we ever imagined. The quiet spaces between the stars aren't empty, they're full of secrets, and one of them just paid us a visit.